What's up mga ka-ChE? It's KD here and I'm back with another unit operations discussion. So we're finished with evaporation. So now we'll go to filtration. So filtration is one of the subjects, the fields in unit operation that I'm not really knowledgeable of. So hindi extensive yung knowledge ko dating sa filtration. So it seems that the chemical engineers that formulated the equations for these are just modeling what they have seen in the physical world and then translated it into mathematical concepts. So yeah, I really don't understand. But now I'll do my best to explain in this video the questions and answers to the reviewer that I'm still using. So I'm still using this. So the reviewer for chemical engineering licensure examination by the MRII. So if you want to solve with me, just you can buy this sa National Bookstore or Shopee or Lazada. So that's what they told me to say to you. Okay, so let's dive right into our lecture for this time. Okay. So we are now in filtration. So filtration. So yeah, I've contrasted here. So in my logo, it is a distillation column, and right beside the this is a filter. So it is an industrial filter. It's so big. So I've seen one in the plant that I had my OJT. So the leaf filter. So leaf filter was so big. Yes, so big, so big, like 2 floors. 2 floors in yung height, and then shaped like a tank. So nado yung mga filter sa sulod sa tank. And that's the leaf filter that I saw in Pilipinas Cow Incorporated, and I had my immersion there. So let's begin with the first one. So the equation that's applied to describe the flow of fluid to a porous medium. So porous medium under laminar condition is, so I was mesmerized by this, or I was confused by this, because this equation does not appear in filtration, rather it appears in fluidization. So this equation is called the ergon equation. So ergon equation, let me write it. Ergon equation. So this is found in this is equation 19-62 in your 8th ed theories. So this is your ergon equation, and then what do these equations represent, or what do these terms represent? So in this part, this is the laminar part. So laminar, and then this is the turbulent part. Yeah, so turbulent part. So we are asked, what is this? So the laminar part of the ergon equation. So obviously this is not Fanning-Darcy equation. So this is not Fanning-Darcy equation because I'm not talking about the flow of fluid in pipes. So that's what Fanning-Darcy equation signifies. So Roth equation is for filtration, which we will be discussing this time. But Hagen-Poiseuille equation is for laminar flow in pipes, okay, in pipes, but not in a porous medium. So the answer here is the Kozeny-Kármán equation. And then this part, the turbulent part, is the Burke-Plummer equation. Okay, so in the fluidization part, so they might say that neglect the only laminar flow, so you neglect the Burke-Plummer equation part, or the flow is turbulent, so you can neglect the laminar flow apart and then just use the Burke-Plummer equation. apart. Okay, so that's it. So number 2, so the iteration by which solids are separated from solid liquids due to the difference in their respective densities. Okay, so this is your keyword, densities. Okay, so it will settle. So the heavier particles will settle at the bottom, and then okay, so yeah, that's we see this in wastewater treatment facilities. Okay, so this is sedimentation. Okay, so number 3, so filtration operating involving incompressible cakes, di ba? And the flow rate is directly proportional to, di ba? So filtration of involving incompressible cakes, so the flow rate is directly proportional to, so that let's take a look at the root equation first. So that's RF, or the rate of filtration, diba? So that's the filtrate volume, diba? And then by with respect to time. So this is the root equation, and this is the pressure drop, and then GC is the gravitational acceleration due to gravity na constant. So that's 32.2 in English, and this is the area of the filter, diba? Filter medium, that's filter medium. Alpha is the resistance of the cake, diba? Resistance of the cake. Mu is the viscosity of the fluid. Yeah. Viscosity of the fluid. C is the concentration of the solids in the original na filter before the mixture goes into the filter, diba? And then lastly is the filtrate volume. This is the volume. So VR, because this is concentrate filtration, and then the VE, which is the fictitious volume. So fictitious volume, it represents the volume that is difficult to obtain, because it's if I may read, diba? So the volume of the filtrate, the fictitious volume is the volume of the filtrate that cannot be collected due to filter medium resistance. Okay, so the higher the filter medium resistance, so the higher the fictitious volume. So most of the time this is neglected, diba? This is negligible most of the time, because the filter medium resistance is low. So the general here is the volume of the filtrate, or the VF or VR here, diba? So this is much larger than the fictitious volume. So VE is essentially 0, yeah, compared to the filtrate volume. So using the root equation, you can see that the flow rate here, is directly proportional to the pressure applied. Okay, not the viscosity, not the thickness of the filter cake, not the size of the cake particles yan. Okay, so yeah, na siya. Number 4, during the filtration of a slurry, the filtration rate will start to fall once the pressure drops across the filter medium. Yeah, so filtration will start to fall once the pressure drop across the filter medium. So it actually becomes constant. Filtration rate will start to fall. Okay, so let me try to show that here. So imagine you have a combination of concentrate filtration and a constant pressure filtration. Okay, so most of the time it starts as this constant rate filtration, or CRF. Okay, so it rises. Okay, the rate will rise, and then such time that the pressure drop across the filter medium becomes constant. So this is the P, okay, or the RF, and then this is your filtration time. So this part is the CPF. Okay, so this is part of the CPF. So the rate falls, so it becomes constant na siya because of the pressure drop. Okay. The pressure drop is constant. That's called the constant pressure filtration because the pressure is kept constant. Okay, so next is number 5. So rotary filter, the precipitate is continuously removed from the filter medium by a scraper in order to, syempre, if you have a rotary filter, so it looks like this. So by the way guys, this is found in your Paris chapter 18. Okay, so just in there. So if there is a slurry here and then there is a knife here, so what do you think the knife does? Diba? So it keeps the filter clean because ang kwan niya is it sucks the slurry here, and then the slurry solid will stick sa surface sa drum, and then it is turning, diba? So it's turning, so madala din ang mga pandra, and then it will be scraped by a scraper because we want to have the filter clean. Okay, number 6, so filtration coarser, the filtration medium, the blank, the concentrate period, so the longer. Okay, kung coarser, if the particles in the filtration mixture is coarse, so concentrate period is longer. Yeah, so number 7, plate and frame filter press, so the rate of filtration is directly proportional to the constant the P&F, so plate and frame filter press. It's what type of operation is that? It's actually a constant pressure, diba? So CPF na siya, CPF. So it's a batch operation. So we have this in our laboratory back in Xavier University. So we have used this. So we made a mixture of calcium carbonate and then water, and then we tried it to undergo in the filtration process. So we used a CPF, and then it is a constant pressure filtration mode of operation. So the solids will accumulate in the filter, and then a series of plates and frames tightly joined together, forming an assembly. So it looks like this. So ma-show yan, and then forgive my drawing. So the liquid will go here, and then there are filter papers here, and then this is tightened na siya screw dia. Just search na lang an image of plate and frame filter press. I can't really draw it here, but so back to the roof equation, diba? Back to the roof equation that I have shown you earlier. So it's directly proportional to, so let's go back to that, diba? So yeah, the cross section, diba? Cross section of the area, diba? Directly proportional siya. It's either sa pressure or sa cross sectional area. So yan. So this is the cross section of the filter surface. Yan siya. Then so for number 8, diba? For a non-washing constant pressure filtration where the resistance of the filter medium is negligible, the maximum capacity of the filter is attained with the filtration time is, yeah, what is this? This is equal down, and I don't know why. Constant pressure filtration with the resistance that is negligible, diba? Maximum capacity is attained with the filtration time is equal. So okay, now we'll go to the problem solving on the part of this video, no? So the rotary, so please read na lang. And then we will solve the numbers 9 and 10, diba? So we have an area of filtration, that's number 9. So this is number 9. So we have a 0.35 now of the area of the filtering area submerged. So if you have a rotary drum, is what I have drawn earlier, diba? So 35 daw of the surface of the surface, no, is submerged, ba? So this we can kana to kana bitang area nga na-covered by the cake, diba? So AC cylinder. So the filtering area, which is kini siya, kini. This is 35% of the area of the cylinder, okay? Of the cylindrical part, okay? Wala siya, pasabot na. So we have the filtrate volume daw, which is 0.61 min per cubic meters per minute per square meter. And then we have our production rate, ba? Production rate of 24 cubic meters per hour. So we can transform that to minute, diba? And then you can find the area of the filter, and then if you can find the area of the filter, then you can find the area of the cylinder, diba? So we can find the AF, diba? AF is equal to 20.4. So just divide that by 60 so that you will find the minute, diba, per minute, and then divide it by 0.61. So this is just, I'm just using a dimensional analysis to get through here, okay? So it's 0.557 cubic meters and square meters, and then you find your area of the cylinder to be 0.557 divided by 0.35, you have 1.6 square meters, okay? So that's letter B, number 9. So number 10, if drum is diameter of 1 meter, so the width of the drum in the centimeters is, so okay, so number 10, we have width dako, no, width, and then this is 1.6 square meters, okay? So I just divide it by pi, okay, pi and pi meters, and then we find then just convert it to centimeters, and then we'll have 50.9 cm, okay? So 50.9 cm, that's letter C. Okay, let's just divide it by pi. Okay, yeah. So number 11, so in a plate and filter, plate and frame filter press, so the rate of washing is okay. So number 11, okay. So number 11, so plate and frame. So plate and frame, yeah. So remember, plate and frame is a CPF, so constant pressure filtration, diba? So the rate of washing is equal to 1/4 of the rate of filtration. So these are just throwing facts at you, so I no longer need to prove them, diba? And then the rate of filtration for a constant pressure filtration is 1/2 of the 1/2 of the VF. So okay, so what are they comparing here is the rate in constant rate filtration. Because constant rate filtration, so in constant rate filtration now is that the rate of filtration in CPF is 1/2 of the rate of in CRF, okay, of the CRF. So that's why we are comparing here, okay? So we have this now, so we can substitute here in the washing, the rate of washing. The rate of washing is just if you substitute that there, you have 1/8 of the VF, then and F, diba? So back to the question, rate of washing is equal to 1/4. So 1/4 of the rate of filtration. Okay, so that's just how it is in constant pressure filtration. So now we will move on to number 12. Number 12 is that we are for 2 hours of filtration time at constant pressure, so we will have to use the equations that we have derived earlier. So washing is done by using 10% of the volume collected, and then time of washing is so we have this. So the rate of washing, so the rate of washing is just equal to the volume of the wash water divided by the time of washing. So this is 1/8 BF, and yan. So we are told that the volume, is 10%. 10% of the volume of the filtrate that was used in volume for washing. So you have a time for washing, and then 1/8, 1/8, and then you have BF, then pila ka minutes, you have 2 hours, or 120 minutes. And then just shift solve, you can find the time of washing to be 96 minutes. Yan. For us, then number 13, this is just maybe it's a bit easy, or a bit hard, but we'll just try to answer this. Okay, so we have a plate and frame filter press, about 24 frames, each 1 inch thick, and inside dimensions of 2 feet to 2 feet. Okay, filtering time is 2 hours. Wash water volume is 10% of the filtrate volume per cycle. Filtering and washing are done at the same pressure, so CPF. Okay, this is CPF. Then final cake is 0.05 feet per feet of the filtrate, and then cubic feet. And then we have, if the time of cleaning is and reassembling is 30 minutes per cycle, the capacity of the press is, so we have this formula, no? So number 13, so we have a plate and frame filter press, which is operated at constant pressure filtration, CPF. You have 2 frames, 24 frames. You have 24 frames, and then the filtration time is 2 hours. Then we are told that the volume of filtration, volume for washing is 10% of the volume of the filtrate. And then we have a C, concentration, is that's right. And then we have we are told that the time for cleaning and reassembling, let's just put it R, or just C, cleaning and reassembling is 30 per cycle, per cycle. So we have to find the capacity, or let's name that Y, so we have to find the volume of the cake. So volume of the cake is just the area, area of the filtrate times the thickness, and then times the number of frames, then you have 8 cubic feet of the cake, and then you have the filtrate volume. Just use the C, so 8 divided by 0.05, and then you have 160 cubic feet of filtrate. And then you have, ganina yapon same equation, same equation is that you can use this. Volume of washing, is 1/8, so just use this whenever you have a CPF operation. Okay, so 0.10 df, and then you have yan, and 1/2, and then we are told that C it's 2 hours, no? 2 hours. So we have the washing time is 1.6 hours, and the time for filtration, diba? It's just na lang, list na lang 2 hours, diba? And then you have 30 minutes. So we have to find our y. So y is equal to the filtrate volume over the total time. So how can we so 160, diba? And then just add the times, okay, then plus 0.5. This is the 30 minutes, diba? And then we are told that capacity, diba? So we are just trying here. Let's try the per day per day, so per day. So let's divide these hours by 24, diba? So just to test the units, okay? So because the units are very different here, so just use the day, the time frame. So this is equal to 936 cubic feet per day, and which is meter B. I just chose that because it's easier, and it's so that I will not waste time. Okay, so number 14 is a bit of a math problem, diba? So we are taught siya. So the problem here is that capacity of a rotary vacuum filter to change by a factor of blank, diba? If the submerged area is increased by 20% with the speed and pressure remaining the same. So in our review, we are asked of the actual values and then this problem. But here in this review, we are asked in the difficult problem dritso. So let's see if we can solve this, no? So yeah, this is a rotary vacuum filter, so okay, so this will be the drawing. You have okay, so this area, okay, so what is being referred to in this problem is this area, the segmental area, okay? If you increase that daw by 20%, okay? So 120 na increase. So let's just say it increased in size, so ito na siya. And then you have this, okay? So this is the radius, this is the h, this is the radius. It still remains the same, and the h, okay? So obviously it did not it decreased, okay? So you're asked to capacity, the capacity if it is increased by 20%. So finish siya. So just how do we solve this is that by solving for this area, this angle, okay? So for this angle, because this is what has been taught also to us by our teacher. So I'll reveal our teacher later. So the segmental area, diba? So segmental area, so the segmental area is equal to, so actually you can derive this when go for your math, but we have a formula for that na. So, and we have r squared sine b beta cos beta. Okay, so we have to assume values here na lang, no? So for it to be easier, No? So because that's what I did also. Let's assume, just throw in numbers here. So beta 1 is equal to 50 degrees. So because we're looking for the angle, diba? So, and then r, so the radius, 0.5 meter. Okay, so plug in everything here. So you will get your A1, A1 can get 0.0951 square meters. So A2 is equal to 1.2 of the A1. Okay, so just multiply that by 1.2 and then you will have a 0.114 square meter. And then just plug that back into our our equation, 1.4, and then find B2, the beta 2. Okay, so we have that, then have this sine beta 2 cos beta 2. Okay, so you can find that as beta 2 is equal to 53.53 degrees. And then if you compare that, B1 53 over 50, diba? You can find that it is 1.07 or 1.1. Okay, so that's what I did to solve this problem. That's letter C. Number 15. So number 15, this is the last problem for this video, no? Okay, so because we are hitting the 30-minute mark, diba? So I'll just understand this, diba? So just read it. When I solved this also, I really got confused to this, diba? So you have a time of cleaning, 6 hours, diba, per cycle. And then you have dW, diba, is equal to the 1/16 daw of volume of filtrate. And then you have total time of 1 day or 24 hours, diba? 4 hours. So 24 hours, and then you will find the time for washing and filtration, diba? So just given here the time of cleaning, but we are not given the time of filtration and washing. So let's assume that that's all there is, no? So time of filtration, time washing, then plus 6 hours, diba? Time of cleaning, diba? So 6, that's 18 na siya. And then treat this as your first equation, because you have two unknowns, diba? So we have to find the second equation, and then we are told, diba, kini? So let's use this. So BW 1/8, diba? 1/8 man siya of the VF of F, kana siya. So just substitute this, diba? Substitute lang. 1/16 VF, 1/16. Okay, so you have stop it. Let's move right here, no? VF over siya ay W, and then you have 1/8 VF over siya, just then we'll have your second equation, diba? So 1 over have 2 over F. So that's theta F, no? So then we'll have 1/2 F, and just transpose this to this side. Okay, is 0. 1/2 F, and then you will have your second equation, and then solve simultaneously equations 1 and 2. You'll have your washing time to be 6 hours, and then your filtration time 12 hours. So that's how I solve this, no? So no need for this. I don't know why they put that there, diba? So it's really a confusing data, but you don't really need it. Okay, so that's the end of the videos. I hope you enjoyed it, and then if you enjoyed it, so if you liked it, please give it a thumbs up, diba? And then leave a comment below if this has greatly helped you, and because I really appreciate, it really warms my heart if someone messages me. I really helped them in their exams, diba? Especially the students from other universities other than my own. So I've really never heard of one, although there are first years, no, but the other my juniors in my school, I haven't heard of them, but I have helped them. But it's okay, that's okay. Okay, so that's okay. I hope to see you in the next one. Bye.